Hello friends, today we are going to solve this very popular problem 2 sum. It's a pretty basic problem for beginners and I like this problem because it tests your skills on different kind of complexity, data structure and overall it makes you become a better programmer. So to start you are given a array of numbers and you are given a target value and you have to find two positions where the numbers you add it will result in a target value. So for example, here the input array is 1 4 5 11 and the target is 9. So if you add 4 and 5 it will sum equal to 9. So the answer will be index 1 and 2 because in most of the programming languages index start from 0. Similarly on 636 target equal to 12, and if you sum first number and last number it will be equal to 12, so you have to return 0 2. So here like we can start thinking about this one. So one of the like basic intuitive idea will be just like picking up any two index and try to see if their sum is equal to target, and if it is yes then return that number. So in this implementation here I'm iterating through all the numbers, and then the second loop is there, and if I'm adding them, then if equal to target, then answer is ij, and I am returning answer. So here the time complexity will be order of n square because we are running two full loops n and n. And what is the space complexity here? We are not storing any additional uh, big amount of memory, so it will order constant, like order of one. You may wonder, okay, vector into this answer, but it has like only two elements, so it will still count as constant memory, order of one. So here, like I have written some test questions and some test cases, and let us see if it works. So yeah, so it's working. So only so issue here is like it is order of n square. So my question is, okay, can we improve this better? Definitely we can. So we can use a index or hash map here. So I'll just like use these solutions for order of faster solutions. So let me just so here I'm using one map for scene. So we are iterating through the numbers, and whenever we see a number, then we are going to just like record it in this it's a hash map. So for every element here, we are iterating through the array and see, okay, if this number, then what we require. So if we require 4, then if we want, then we will check in the scene if we have seen this number before. And if we have seen this number before, then answer is those two indexes. And once we are done with this check, then we can just like mark, okay, I've seen the current number at index I. So let me walk through the example. So here in this array, 1 4 5 11 and target is 9. So I will start with 1, and then now I need how much you need, like you need 8 because 9 minus 1, if we have 8, then we can just like add to index and target will be 9, but we don't have 8 so far. Now we are at 4. So 4 for 4 we need 9 minus 4 equal to 5, but we have not seen any 5 yet. So we just like mark, okay, I've seen 5 at index 1. When I'm at 5, I need 9 minus 5 equal to 4. But yeah, we have seen 4 here on the index number 1. So we say, okay, now we have found two solutions and return 1 and 2. So that's how this hash map solution is working. and let's see if it works for this. Uh, so yeah, let me check the solution is working. Yeah, this solution passes all the unit test cases. Now coming to complexity analysis, starting with the time complexity. So here we are doing only one loop that has like n steps, and here we are looking for the map. So we can assume safely that the hash map works for order of one in most of the implementation. So overall, the time complexity is like order of one, order of n. Sorry, order of n is the time complexities. And on the space complexity size, we are storing all numbers. See if here for every loop, so space complexity is bigger here. It will be like linear order of n. So compared to previous solution, this solution is better for fast speed, but it requires more memory, and the previous solution was slow but required less memory. So yeah, you can discuss this kind of trade-off with your interviewer, and if you have any further questions, drop in comment and I'm happy to answer. Okay, bye.